Good evening. Today we are recording the solution um, video for electrochemistry test number 13. Okay. This is the solution for first question. First question states that resistance of 0.2 molar solution is given 50 ohms and its specific conductance is 1.3. Okay. The resistance of 0.4 molar solution of same electrolyte is 260 ohms. We have to calculate molar conductivity. Okay. Yeah. So to do that, same electrolyte is used. So what we can say, cell constant will be what? Same. Okay. So from this, what we can calculate? First, we will calculate cell constant from first data. Okay. That will be equal to R into K. Then after that, we can calculate what? Specific conductance for 0.4 molar solution. Once that is calculated, molar conductivity is specific conductance upon concentration. What thing is important here is that concentration, we have to convert volume in meter cube. So after that, you will place that value of concentration in this question. Okay. After solving that, what you will get? You will get option B as the correct answer, where molar conductance will be 6.25 into 10 to the power minus 4. Question number 2. The reduction potential of hydrogen half cell will be negative if. So see, uh, reduction potential means H plus will get reduced to hydrogen gas. This is the reaction mentioned there. Okay. And we know for hydrogen is considered as the reference cell, and E naught for hydrogen is what? 0. Okay. So E to be negative for this particular reaction, we can consider it that pressure of H2 or hydrogen gas should be what? Greater than the concentration square of H plus. And option A satisfies this condition. Okay. So answer will be option A. Question number 3. Reduction potentials are given for 3 metals: zinc, nickel, and ferrous. Okay. Um, and their values are given. And a reaction is mentioned there where X is getting oxidized, whereas Y2 plus is getting reduced to Y. Okay. So here, by observing the reduction potential, we can conclude that zinc is more reactive metal than Fe than nickel. So here zinc will get oxidized to Zn2 plus. That is, X will be zinc, and um, it will easily reduce nickel as compared to Fe. Okay, so Y will be nickel. Option A will be the correct answer. Question number 4. Strongest oxidizing agent. We are having values of E naught cell or reduction cell for Cr3 plus to Cr. Okay, MnO4 minus to Mn2 plus means plus 7 say plus 2. Okay, here plus 6 to plus 3 for chromium, and here chlorine gas is given. Okay, chlorine gas, for chlorine gas it is 1.36. So based on the data, we can clearly observe that reduction potential for MnO4 minus is the highest. So it will be the strongest oxidizing agent. Okay. Question number 5. The standard electrode potential for reaction is, see, the reaction is given here where tin is getting oxidized, whereas silver is getting reduced. Okay. So we are having their E naught value also, and we have to calculate standard E naught value. Okay, for cell. So it will be what? Sum of oxidation E naught plus reduction E naught. Oxidation is occurring for tin, whereas reduction is occurring for Ag plus. So by adding 0.2 plus 0.14, we can get the E cell value. Okay. Remember in question for tin also reduction potential is given. Oxidation potential will be negative of reduction potential. So answer will be option D. Question number 6. Resistance is given for 0.2 molar. Okay, specific conductance is given for that solution, that is 1.4. Now the resistance of 0.5 molar solution is given. And molar conductivity, we have to calculate molar conductivity for 0.5 molar solution. See, it is similar to question number 1. Okay, in this question we can again calculate what we can calculate cell constant, and from that we can calculate specific conductance of second solution where concentration is 0.5 molar. After calculating, just we have to place the calculate what molar conductance, that is equals to K upon C. Point we have to consider is that we have to convert this volume in meter cube for in that concentration term. Okay, and that after converting that you can calculate the answer. So answer will be 5 into 10 to the power minus 4. Option C is the correct answer. Question number 7. Standard reduction potential is given for half cell of MnO4 minus to Mn2 plus, where it will act as an oxidizing agent and it will reduce what? Chlorine, bromine, iodine. Okay, and their reduction potentials are mentioned. Okay, so we have to see which of the following halides can get reduced by can be which of the following halides can get oxidized by MnO4 minus. Okay, so here we can easily see the half reaction is mentioned there, where Mn plus 7 is getting reduced to plus 2. Okay, in acidic medium. pH of the medium is plus 3. And so what we can conclude here, concentration of H plus will be 10 to the power minus 3. So E is equals to what? E naught minus, then at standard condition, we can consider 2.303 into R T upon F equals to 0.06. Okay. So here we can easily see that after calculating E, which is equal to 1.22 volt, we can conclude that MnO4 minus can oxidize what? Br minus and I minus ions. Okay, so option C will be the correct answer. Here it will be Br minus and I minus, Br minus and I minus. Okay. Question number 8. An external cell is applied to galvanic cell of zinc and copper in this question. The E cell of zinc copper cell is 1.1 volt. Okay, if and the connections are in opposite direction, means it will oppose the flow of the galvanic cell. Okay, if E external is less than 1.1, then what we can say? The current flow will be in same direction, but the magnitude of flow will be reduced, or the number of electrons flowing per second will be reduced. Okay, for the case where E external is less than 1.1 volt, but it will act as a galvanic cell, so electrons will flow from anode to cathode. Okay, but for the second case, when E external is greater than 1.1 volt, then reverse flow of electrons will take place, and electrons flows from cathode to anode, and it will act as electrolytic cell. Okay, so option B will be the correct answer. Question number 9. 2 Faraday of electricity is passed through the solution of copper sulfate. See, copper will get deposit here, and copper is in +2 oxidation state in copper sulfate. So 2 electrons a transfer is needed to for the deposition of copper. Okay, and for 1 mole deposition, 2 Faraday will be needed. So we can conclude that for 2 Faraday electricity, 1 mole of copper will be deposited, and that is equals to 63.5 gram. Option D will be the correct answer. Question number 10. A block of copper metal is dropped in zinc sulfate solution. Zinc is more reactive metal than copper, or what we can say, reduction potential of zinc is smaller than that of copper. Okay, so no reaction will happen here, or copper will not displace zinc from its solution. Question number 11. Oxidation of succinate ion is happening. It is getting oxidized into ethylene and CO2. Okay, reaction is mentioned here. So oxidation will occur at anode. During this oxidation process, 2 electrons are transferred. Similarly, at cathode, water will get converted into hydrogen gas. So we have to calculate total volume of gas at STP. So here ethylene and carbon dioxide and hydrogen are the gas emitted. Okay, so as we can see, 0.2 Faraday of electricity is used, and 2 electrons transfer is observed in the reaction in cathode and anode. From that, what we can conclude, 0.2 moles of CO2 will be released, 0.1 mole of hydrogen will be released, and 0.1 mole of C2H4 will be released. Or total moles of gas released will be 0.4. By multiplying it with 22.4, we can obtain the amount of gas released in liters, and that is equals to 8.96 liters. Option A is the correct answer. Question number 12. Strongest oxidizing agent, we have to comment on strongest oxidizing agent. Okay, oxidizing agent means self-reduction. Self-reduction will be forward for which reaction we have to check. Okay, so reduction potential should be what? So, sorry. Strong reducing agent, we have to answer strong reducing agent. So strong reducing agent means self oxidation. Okay, or strong reducing agent means it will oxidize itself, it will reduce others. Okay, so reduction potential should be low for that case, and chromium has the lowest reduction potential of the given values, which is equals to minus 0.74. So answer will be A. Question number 13, which is the standard reduction potential E naught for Fe plus 3 to Fe. We are given with two reactions, and we know that we can't directly add E naught values for reaction, or E naughts are not additive in nature. So, but we know that delta G or energy, Gibbs energy, is additive in nature. So we will first calculate delta G value for the given reactions, and after calculating that and doing the addition of the reaction and obtaining the main reaction, that is Fe plus 3 to Fe. Okay, we will calculate delta G for that reaction, and we will calculate E naught for the given reaction. Means we have to depend on delta G, and after doing the calculation in terms of delta G, we will calculate E for the Fe plus 3 to Fe reduction. Okay, and after doing this calculation, we will get value equals to 0.056 volt, minus 0.056 volt. So option C will be the answer. Question number 14. To find the standard potential of M plus 3 to M electrolyte. So we have to calculate the reduction potential of M metal. Okay, and we are given with a reaction here, where silver is getting deposited or reduced, and M is getting oxidized in this reaction. Okay, so we have to we are given with E cell value, that is 0.421, Okay, so we will calculate E naught with the help of the given data mentioned here. Okay, and E naught calculated is equal to 0.481 volt. Okay, 0.481 volt. Now E naught cell is equal to what? E reduction potential plus E oxidation potential, or we can write oxidation potential in terms of reduction potential also. That is equals to minus of reduction potential. From the given values, we can calculate E reduction potential for M metal, that is equals to 0.32, which is very close to option A. So answer is option A. Question number 15. When 9.65 ampere current was passed for 1 hour in nitrobenzene in acidic medium, its amount of para-aminophenol produced is. See here, first we can calculate how much charge was supplied for 1 hour. So it was equal in Faraday. So it was equal to 0.36 Faraday. Okay. After that, what we have to observe is how much electrons are transferred during the conversion. Okay. So NO2 is converted into NH2, where N was in +3 and later it was in -3. So nitrogen oxidation state was changed, or 6 electrons were gained by nitrogen in this process. And we can observe that on the para position, earlier it was hydrogen, later it is OH group. Okay, so carbon's oxidation state is changing there, and carbon is losing 2 electrons. Net change in electrons are 4 electrons. Okay, and 4 electrons are gained during this process. So for Faraday will be needed for 1 mole of conversion. Okay, and for 0.36 mole we can apply unitary method, and we can get that 0.09 moles will be produced during the process, and after multiplying it by its molecular mass we get 9.81 gram. That is option D. Okay, question number 16. E naught values are given for different cells. Okay, and we are making a cell of these metals with zinc. And we have to calculate the maximum E cell value per electron transfer for all the cases. So we have calculated here E naught values. You can directly add the E naught values here. Okay, oxidation plus reduction values, and we can calculate it. So after seeing what we have to do after calculating each cell, we have to divide it by number of electron transferred during that conversion. So in the first reaction, where the gold 6 electrons are transferred during the process. So in second, with silver 2 electrons are transferred. In third, with Fe +3 to +2, 2 electrons are transferred. And in fourth, again, there is a transfer of 2 electrons. Okay, there is a transfer of 2 electrons, and we can easily see that highest value will be what for silver with zinc cell. Okay, if we are having a cell with silver and zinc electrodes, so option B is the correct answer. Question number 17. We have to calculate K equilibrium value. Okay, we are given with E naught cell, and we can see that the reaction is in equilibrium as equilibrium constant. We have to calculate equilibrium constant. So what we can say, E cell will be 0 at equilibrium. Okay, so E naught cell will be equals to RT NF ln K, and by placing the given values here, we can find that ln K is very close to 161. Okay, or what we can say, K will be equal to E ki power 161. Option A matches to this answer. So what option A is the correct answer. Question number 18. Given the equilibrium constant Kc for Kc is given for this reaction. Okay, calculate E naught cell. Similar question, same formula we can use to calculate E naught cell. E naught cell will be 0.48 when we are using the value of at standard condition. We are taking the approximation at 0.06 for 2.303 RT upon F. Okay, so option B is the closest one. Question number 19. Delta G of the cell. We have to calculate delta G. Okay. Okay. What we are doing, we are multiplying that equation by 2. Okay. So we are having first value is also delta G for cell. When we are multiplying it, we can directly multiply delta G by 2. So answer will be what? Option C. Okay. Question number 20. E naught reduction potential for nickel is given, gold is given, and standard EMF of voltaic cell. Okay, cell is also given. So in this cell, nickel is getting oxidized, whereas gold is getting reduced. We have to calculate standard EMF. Okay, so this to calculate that, first we will calculate what E naught cell. After that, E naught E cell will be equal to E naught cell minus 0.06 upon total transfer of electron during this reaction is 6. Okay, so we will take n factor as 6. Then we are having the concentration of nickel and gold ions. Okay, we will place that values and we can obtain the answer. See here, while observing the calculation, in log, we will get one value as molar concentration for both nickel and AU is given 1. So what we can conclude that log 1 is 0. So E cell will be equal to E cell naught. Okay, that will be equal to 1.75. Option C is the correct answer. Question number 21. Now integer types questions are starting here. Okay, we have to calculate E cell. Okay, for the given half cell reaction at pH equals to 5, means we are given with what concentration of H plus. Okay, that is 10 to the power minus 5. Here water is getting oxidized, oxygen is getting oxidized, and O2 is released. Okay, during this reaction. So E cell will be equal to E naught cell minus 0.06 upon transfer of electrons are 4. That's by n factor will be 4 log H plus concentration ki power 4. Okay, by solving this expression, we will get E cell value equals to minus 0.93 volt. Okay, and 100 times of E will give us 93. So answer is 93. Question number 22. Okay, at equilibrium we have to calculate the thing. So what we can conclude, E cell will be 0 at equilibrium. At equilibrium, okay, it will be 0. So E cell naught will be equal to 0.06 upon n log ratios of concentration, and we have to calculate that ratios of concentration. Okay, E cell, after calculating that, we can conclude it equal to 10 to the power 1 by 3. Okay, and that will be very close to 2, and the nearest, we have to answer the nearest integer, so it will be 2. So question number 22 answer is 2. Question number 23. Silver is given 108 gram is deposited. See, 1 mole of silver is deposited, means 1 Faraday charge will be needed for deposition of 1 mole silver. Okay, now that charge, if we are comparing it with what other reaction, oxidation reaction of water. Okay, so in that reaction we can clearly observe that 4 electrons are needed. Okay, so to release 1 mole of O2 gas, 4 Faraday charge will be needed. 1 Faraday charge will produce 1 by 4 moles of O2 gas, or 1 by 4 is equal to around 6 liters of gas, or closest integer is what? 6 liters. Okay, so answer will be 6 for this question. Question number 24. We have to calculate 10x value, where x is hours, for time, in hours. Okay, time where electricity is passed and the current is passed by 100 ampere. Okay, see, so charge passed will be equal to 100 into 3600x. Here combustion of diborane is happening. Okay, so yeah, it is clearly observed that the amount of diborane burned is 1 mole, or 1 mole of diborane is burned. So we will need 3 moles of oxygen during this process. Okay, and oxygen, what we can conclude here, 1 mole of oxygen is obtained uh, during the oxidation reaction when 4 Faraday of charge is passed. For 3 moles of oxygen, we will need 4 into 3, 12 Faraday charge. Okay, so x value after calculation will be equal to 3.216. Okay, or it is very, after rounding it, we can conclude it to 3.2, and 10x value will be 32. Okay, so answer is 32 for question number 24. Question number 25. When an electric current is passed through acidified water, this much of hydrogen is produced at NTP. Okay, so H plus is getting reduced, okay, to hydrogen gas. During this process, 2 electrons transfer is there. So we have to calculate the current pass first to solve this question. Okay, so what we can say, for 1 mole at STP 22.4 liters is occupied. Okay, or what, 1 liter will be released for 1 by 22.4 moles. So we can calculate the moles of gas needed, that is 1 by 200. Okay, again, 2 electrons were needed for 1 mole. We can say 2 mole of hydrogen gas, 2 Faraday was needed. For 1 by 200 mole, it will be 1 by 100 Faraday. Okay, and we can calculate the current with the help of this. 1 by 100 Faraday is equal to 965 Coulomb. Okay, and time is given. It takes 965 seconds to transfer 965 Coulomb. So current is 1 ampere. So we have to calculate 10 A value, that is equals to 10 ampere. Okay, answer is 10. Question number 26. A current of 9.65 ampere is passing for 16.40 seconds. This 16.40 second is equals to 100 second. Huh? This value is very nicely presented. So we can calculate charge. Charge will be equal to 9.65 into 100, or 9650 Coulomb. Okay, and tin is getting reduced. So we can observe that the value here 5.95 gram is actually 0.05 moles of tin. And we have to calculate the oxidation state of that tin. Okay, so x Faraday, if change in oxidation state is x, so for x Faraday 1 mole tin will get deposit. Okay, and we know that for 1 by 10 Faraday 0.05 mole was deposited, or for one, what we can say, x value is 2 for this reaction. Okay, we are using unitary method here. Question number 27. The time in seconds to coat a surface of with silver. We are coating it. Okay, a surface of metal with silver by passing this much current. in silver nitrate. Okay. So first we will calculate amount of silver deposited. As we are given with area and thickness, we can calculate volume. Volume equals to 0.4 centimeter cube. Okay. Of, we are having density. So by density, we can calculate mass of silver deposited. Okay. Mass is equals to density into volume. After calculating that, we can calculate moles. Again, transfer of electrons are 1. Okay, by applying unitary method, we can easily find the time taken for the deposition of that silver from silver nitrate solution, and the time is equals to 40 seconds. Question number 28. Mn 3O4 is getting converted to Mn O4 2 minus. Okay, so earlier it was in plus 8/3 oxidation state, later it is in 6 oxidation state. Okay, plus 6. So we can calculate the n factor by the change in oxidation number of the reactant into 3, as 3 atoms of Mn is present in that molecule. Okay, so the n factor for this reaction is 10, or what we can say, the charge required for 1 mole of deposition will be conversion will be 10 Faraday. Okay. Question number 29. 1 gram metal M2 plus was discharged by this much electrons. What is the atomic weight of metal? Okay. See, we are mentioned with electrons, so we can calculate the moles of electrons used. Okay. Also, plus 2 is getting converted into getting reduced to metal. Okay, and what we can say, 2 Faraday will be needed for to obtain 1 mole of the metal. Okay, or we know that charge of 1 mole of electron is 1 Faraday. Okay, so 0.02 Faraday will gives us is giving us 1 gram of metal. So from this we can conclude that 2 Faraday will give 100 grams of 100 grams of deposition, that is equals to 1 mole. Okay. Question number 30. We have to calculate 1000 alpha. Alpha is degree of dissociation of acid. Okay. So first we will calculate molar conductivity of molar conductance of acid. Okay. Then we will calculate the alpha dissociation, that is equal to molar conductance upon standard molar conductance. Okay, standard molar conductance is given. So alpha was calculated 1/8. 1000 alpha will be equal to 125. Question number 31. E naught is given. E naught by dt for the cell is given. That is okay. The reaction for the cell is given. It is copper and zinc galvanic cell. Okay, the standard delta H reaction we have to calculate. See, so from the given data, what we can do, we can easily calculate delta G naught. Okay, and we are having a relation between delta G naught, delta H. Okay, the delta G naught equals to delta H minus T delta S. Or we can replace it by delta H equals to delta G naught plus T delta S. Also, delta S is equals to NF E D naught upon dt. By placing the values, we can easily calculate delta H naught, and it is equals to minus 411 kilojoule per mole. It is very close to option A. Okay, so answer is option A. Question number 32. Reduction potentials are given for some metals: zinc, copper, magnesium, nickel. Okay, reducing power, we have to talk about reducing power. Okay, so reducing power we can relate by self oxidation. Okay, so lower value of E reduction will have what more reducing power. So calcium will have the highest, then magnesium, then zinc, then nickel. Option B is the answer. Question number 33. We have to calculate standard electrode potential, okay, for the reaction. So this is the reaction here where H2 is getting oxidized to H plus and silver is getting reduced. Ag plus is getting reduced to Ag. Okay. E cell can be calculated here. E cell is given, sorry, E naught cell. We are calculating E naught cell. H plus and Cl minus concentration is given to us. Okay. As molality is given of HCl. Okay, and it is very low. The value of molality is very low. So we can directly put the same value as molarity, or we can consider that mass of solute is negligible when we are relating it with the mass of solution. Okay, so molality can be taken as molarity and solve this question. By solving this question, we can obtain E naught cell equals to 0.2. Option A is the correct answer. Question number 34. Question number 34, we have to calculate the amount of Pb getting dissociated, okay, electrolyzed. Okay, so we can easily see that Pb will go to +2 oxidation state. Okay, so 2 electron transfer is there. So for breaking it, we will need 2 Faraday for per mole of PbSO4. Okay, as N factor is 2. Or for 1 Faraday, we can have half mole. The current pass during this process or the electricity passed is 0.05. By applying unitary method, we can calculate it and we can see that the value of PbSO4 deposited is around 7.6, electrolyzed is around 7.6 gram. Okay. Question number 35. E naught reduction cells are given. Okay. For copper 2 plus, copper 2 plus to copper plus to copper. We have to calculate E naught for reduction for copper 2 plus to copper plus. So here we can't directly add them. So we are doing what? We are just converting them in delta G values. And after converting that, we are calculating the E naught for the required copper plus 2 to copper plus 1. Okay, reduction potential, required reduction potential. And we obtained it as 0.158. The option A is the correct answer. Question number 36. We have to find out which one of the following is incorrect. By observing option A, we can clearly see that Br minus minus I minus is not equal to K minus minus K plus minus Na plus. Okay, option A is the wrong answer here. Wrong match. Question number 37. Which has the lowest ionic conductance at 298. So distilled water has the lowest ionic conductance. Water from well, it will have minerals. Saline water will have what minerals? Okay. Then sea water will also have minerals in them. 38. Electrons are given. We have to calculate gram equivalent. See, electrons are given, we can calculate the moles, and by that we can conclude that this much moles, this much 10 q or minus 3 gram equivalent will be obtained. So option C is the correct answer. Question number 39. Okay, silver nitrate, copper sulfate, and AlCl3 is given, and 1 Faraday charge is used. So we know that 1 electron is needed for Ag, for copper 2 electron, for Al 3 electrons. Okay, so 1 Faraday will deposit 1 moles of Ag, half moles of copper, and 1/3 mole of aluminum. So their ratios or ratios of Ag, copper and aluminum will be 1 ratio, half ratio, 1 by third, or we can simplify it to 6 ratio, 3 ratio 2. Option B is the answer. Question number 40. Okay. A reaction is given where tin is getting oxidized and silver is getting reduced. Okay. So they are asking us to increase the E cell. How the E cell value will increase? See here, E cell is equals to E naught cell minus RT upon NF ln Sn plus 2 upon Ag plus 3. Okay. So to increase E cell value, what we can do? Ln value should what? It should be smaller. Okay. It should decrease. As ln value decreases, it will increase the E cell value. So ln value can be decreased by increasing the concentration of Ag plus or by decreasing the concentration of Sn2 plus. Okay. So option C says as the increasing concentration of Ag plus. Correct option is option C. These are the solutions for our class test number 13 for electrochemistry. Okay, thank you.